Good evening. My name's Matt. I'm from Mockingbird Consulting, and we help people make better decisions by using the Internet of Things and the data that they collect from it. I've come to give this talk this evening because my background is very much systems administration. I've been doing DevOps for about 8 years. I used to work for DevOps guys down in Cardiff. I'm currently implementing stuff for all sorts of insurance companies and things like that. And I'm also trying to build hardware at the moment for the Internet of Things, and this is throwing me a whole load of brand new challenges that I've just never encountered before. With software testing, it's easy. You write your unit tests, your function tests, your integration tests, whatever. You have Jenkins or Circle or Travis or whatever. Run those through, you spin up virtual environments and everything like that, and everything comes back green, and you merge your code, and you go home feeling really pleased about yourself, right? This is a daily occurrence for all of us, I'm sure. How do you know that a colour-changing LED is the right colour that it needs to be, given a particular variable that's been passed to it by a temperature sensor? How do you detect that automatically? How do you make sure that when the sun hits the solar panel that starts your solar panel fan, solar-powered fan, that fan starts spinning at a speed that is safe for the user who has it embedded in their baseball cap and isn't just going to melt their face? Okay? These questions are difficult. I don't have answers to all of them yet, but what I am finding is that there's a lot of things that I've picked up over the last 8 years when I've been talking about DevOps that do port quite nicely over to the hardware world. I am going to do a very, very, very brief thing of what DevOps means to me, because we've got nearly 80 people in this room, which means there's at least 150 different definitions of DevOps in this room. For me, DevOps is about collaboration. The tools are secondary. It's about breaking down silos. It's about getting developers and operations, and these days security, and product analysts, and business analysts, and sales, and marketing, and even the tech support teams, working as a single unit to produce a quality product. And the best analogy I've got for this is, if you were to go into hospital, and I hope none of you do, but if you were to end up in a hospital, you wouldn't expect the surgeon to collect your notes from the filing department, the anaesthetist to go and collect your drugs from the pharmacy, the ward clerk to carry out your heart surgery, and a nurse to go and evaluate your home afterwards to see whether it was fit for you to live in. We have specialists for a reason. In medicine, when we come to the IT world and software development, we should be looking to having a team of specialists that are working on the same product to produce the end result that everyone needs. I'll stop ranting about that now. So, why bring DevOps to the Internet Thing? I've touched on this briefly already. I'm conscious of time. I'm well aware you all want to get down the pub. I'm quite keen to get back to Monmouth, where I live. So, I want to bring this because I want to improve collaboration. I am seeing silos being built. I am seeing the hardware people going, well, what do you mean it works on your laptop in the simulator? It doesn't work on our device we've got here. Works on my machine. Everyone familiar with that one? There's someone who I know very well. Someone once said to him, well, it works on my machine, to which his answer was, well, back up your email, we're sending your laptop to the data center. And actually, I think that's not a bad opinion to take. I want to improve the iteration times. Iteration on hardware is really hard, especially if you don't have the ability to manufacture your own printed circuit boards and things like that. At the moment, when I print a circuit board, when I design a circuit board, I have to send it to China or America or somewhere like that to get a rapid turnaround. And a rapid turnaround is about 2 weeks, and it costs me about 35 to 40 pounds for 5 circuit boards. So every time I need to make a change, and I need to test that change, it's a 2-week wait as a minimum whilst I wait for those boards to come back to me to test. I want to increase the ability to test, which is what I was saying earlier on about detecting the colours and things like that, and I want to automate those tests as much as possible. But it does come back to collaborative working. And I love this quote from Henry Ford, this idea that you begin with coming together, but it's not until you're working together that you're actually successful. And a lot of the tools that we use, and were mentioned in the previous talk, the one thing they all have in common is that the output from those tools is that they're text-based. the code, the Docker files, and everything else. So we can store those in Git, or SVN, or CVS, or whatever your flavour of choice is, and we can share those amongst teams. And therefore we can collaborate. And what I've found is that actually there's a number of tools, like OpenSCAD, KiCad, the Arduino IDE, and they output in plain text. OpenSCAD allows you to design 3D models, and you literally write it as code. You say, I want a cube that's 5 by 5 by 5 millimeters, and I want you to move it 20 millimeters to the left, and this is how I design all of my cases for my Internet of Things devices. But it outputs in plain text, so I can save that in Git, and I can push it to a central repository, and someone else who's collaborating with me on the design can check out that code, and they can say, okay, well actually we need to move it 19 millimeters to the left instead of the 20, and they can commit and push back, and we can do pull requests and all the rest of it. KiCad is for designing PCBs, and again, the output from that is plain text. So PCB design can be worked on across global teams. And the Arduino IDE, for those of you that don't know it, I'm going to get told off and make a lot of people angry for this, but it's effectively a subset of the C programming language-ish. But again, the output effectively is plain text before you compile it, before you get your binary blobs that you can send off to the Arduinos and things like that. So we can share all of that through Git. And that's exactly what I do. I use exactly the same procedures that you'll all use for your software, for your infrastructure as code and things like that, for code reviews, for pull requests, for merging, for branch management, things like that, be it GitLab, GitHub, Bitbucket server, or anything like that. And then the final stage is the creation. Now, as I said earlier on, I don't yet have the ability to manufacture my own printed circuit boards. These are two of the companies I use, OSH Park, Seed Studio. This is not an endorsement, they are just people that I use. And as I say, the iteration time is 2 to 3 weeks, depending on whether you're prepared to pay FedEx extortionate amounts of money to ship something that's absolutely tiny from Hong Kong back to you. But what these companies take as input is something called a Gerber file. A Gerber file is plain text. So I can generate that from KiCad. I can save it in GitHub or GitLab or whatever, and I can actually version the boards I've got by using the Git logs, by using the change logs and all the kind of things that we're used to using to manage software. Improving iteration time, and I am galloping through this, I apologise in advance, is probably one of the biggest challenges, and that's before you get to, I'm sending these files to China, please send me back a PCB. As I've said, with software, you write your code, you commit to Git, Jenkins goes off and does whatever, be it in Docker containers, VMs, Lambdas, whatever. And you run all your unit tests, and if they come back, it's great. If you're testing an Arduino, and I wish I brought one with me, for those of you that don't know, the Arduino is a circuit board that varies in size from about 2-inch square down to the latest ones I've got that are actually smaller than my thumbnail. And they run all these different languages, but they don't all have the same chipset in them. So if you think of it as trying to write compiled code that needs to run on both Windows, Mac and Linux, that's the kind of challenge that I've got, but I'm doing it with hardware. So what I use is Raspberry Pi Zeros as my Jenkins build slaves, and I use Jenkins because it's what I've been using for the last 10 years. I know it inside and out. And as long as you think about Jenkins as a glorified task runner with a fairly ugly web interface, it's pretty, well no, Blue Ocean is a marked difference, and I'm very glad for it. Jenkins will pretty much do whatever you want to, and it only blows up when it does something either A, it doesn't understand, or B, the test failed. So it's quite resilient in that case. So what I do, I have a Jenkins server that runs, it talks to GitHub, it pulls the code down, it shoves it onto a Raspberry Pi, Pi Zeros in my case. They have the Arduino IDE and various other things installed on them, depending on which chip is connected to the USB port, and there's one Pi Zero per type of chip. So in the same way you'd have Windows, Mac and Linux, at the moment I'm developing for the Atmel AVR series, and I'm developing for the SAMD32 series of chips, which have different instruction sets. And I have two Pi Zeros, and one has the Atmel attached, and the other one has the SATD attached, and they run as build slaves, so they compile for the relevant chip, flash it onto the device, and then we move on to the really hard bit, which is the bit I haven't quite cracked yet, which is how do we know what colour that LED is? How do we know how fast that motor's spinning? There's a magazine called Hackspace. It's from the Raspberry Pi Foundation. I'd recommend that if you are interested in this stuff, you buy it this month for two reasons. The main one is that Lady Ada, behind Adafruit, Limor-Fried, has been interviewed, and there are maybe 8 pages in the magazine, if not more, about how Adafruit works and how they test each of those shields that you can buy from their website to go onto your Arduinos or your microbits or whatever they are. And the answer is they have a custom test rig. So for every circuit board they manufacture, they're also manufacturing a test rig that they can use to monitor the inputs and the outputs as they go through it. That's the route that I'm going down. The second reason is purely a selfish one, and that's that I'll come on to something called Resin.io in a minute, and the latest version of Hackspace also has an article that happens to have been written by me on how to deploy, well, clocks around your house using Resin.io, but actually it's an introduction to it. So if you're after a good introduction to Resin.io, I've been told that the code works. So that's always nice. So IoT networks. Who here is familiar with what an IoT network looks like, how they run, the kind of technologies that are involved, loads of blank faces, absolutely amazing. This is exactly the same look I got last night when I was trying to explain DevOps to a load of people who, it's a hobbyist group for people who own Raspberry Pis. Try squeezing a talk on DevOps into that. It was a challenge. So what we tend to have, I'll come this side for a bit. So what we tend to have is down the bottom we have our sensors, and they can be the built environment, so they can be temperature inside your office, what your aircon's doing, all of that kind of stuff, humidity. Awesome. It can be custom sensors, so one of the things I'm working on at the moment is a device based on a Pi Zero that uses Bluetooth to get a rough idea of how many people have walked past it. There's obviously privacy implications with that, because what it's actually doing is saying how many Bluetooth devices around me are in scanning mode or connect to me mode. And then it's saying, oh, it's all of these unique identifiers, all of these MAC addresses for all these Bluetooth bits of hardware. So what I've had to do there is write something that makes sure that I'm not logging the time and date that I picked up these devices. But I am logging some kind of unique identifier that means I can batch them and say in the last 10 minutes I have seen this many devices go past. So there's all sorts of sensors you can do. And then you've got the natural environment sensors, so things like river level monitors. If you go to flood.network, it's based up in Oxfordshire, and they are literally monitoring river levels using ultrasonic sensors that are 5 to 10 quid each off eBay. It points at the water, and if the water gets closer to the sensor, it sends off an alarm saying the river's getting higher, and if it goes away again, it goes, we're all good, don't worry. These all then feed back over some kind of network. It can be Wi-Fi. I'm working with something called LoRaWAN at the moment. LoRaWAN, for those of you that don't know it, is very low bandwidth, long distance. So it runs on 868 megahertz, and we're talking a range of 10 to 15 miles line of sight. So for rural environments like the one I live in Monmouth, it's fantastic. We have some very high hills and lots of farmer fields. So I'm working on getting the gateways onto the very high hills so that we can just flood the farmers' fields with sensors and pick up all the information about the environment around us. And as long as we can get the sensors small enough to work off solar power, we don't have to worry about running electricity out to them or anything like that. That then feeds back, in the LoRaWAN case, it feeds back to the Things network. This is a community-led open network for doing processing of data off the back of LoRaWAN. And then from that, I pull things into an analytics cluster. Analytics cluster is probably a bit grand for the prototype I've got running at the moment. It's actually the influx data stack. So it's chronograph and influx DB and capacitor and whatever the other one is. And that then allows me to query all the data. And then we get onto the stuff that actually for me is the most important bit. And that's these three groups of people on the side. So this is something that I send to my customers, hence the wording on it. But effectively, people in the offices can access, the customers of the organisation can access the analytics to look at the data. But this is where the real power lies. If you look at the data sets that have been released by Network Rail, by the Office of National Statistics, by the Welsh Government, I think by the regional governments in the UK, but being the wrong side of the border, as it were, I'm not too sure about what's happening locally here. It's not necessarily the data scientists inside the ONS that have made the best use of the data in the ONS. It's actually the general public. Because the ONS have gone, we've got all this data and we're not quite sure what we should do with it. And the public have gone, I've got an idea, hold my beer, watch this. And this is what I'm a member of the Open Data Institute. I'm a big fan of open data. And what I'm trying to do as much as possible is encourage my customers that where the data is not proprietary, they should give access to it, to the public, for the public to carry out analytics. Especially when it's custom sensors like flood water levels, and it's things like air quality measurements and stuff like that. The gateway itself is deployed, so in my case the LoRaWAN gateway here, is a Raspberry Pi B2 with a custom circuit board and then a radio board on top of that, and that's deployed using this thing called resin.io. Other fleet management services are available, I just happen to like this one. So, a bit about resin.io. That's quite a scary diagram. That's Monmouth, by the way. If you haven't come to Monmouth, come and visit. It's an awesome town. I love it. The way that resin.io works, really handily for this evening, is by deploying Docker onto a Raspberry Pi. Again, last night I had to explain what Docker was. Thankfully tonight I don't need to, because everyone knows what that is now, right? So that's awesome. The way that it works is you have a Git repo, and you have your Docker file, and you say, you do all your code, and you do all your testing and all the rest of it, and then you do git push resin master, and it flies up to resin servers, and resin creates the Docker container for you. And every minute, your devices, I'm using Raspberry Pis, they've got support for BeagleBone Blacks, they've got support for the Intel Edison boards, all sorts of stuff. Every minute, your device phones home over a VPN connection to Resin and says, do you have a new version of what I'm running, please? And Resin either goes, no, says, all right, I'll try again a bit later on. Says, yes, brilliant, I'll download that. And these days, when I first started using it just over a year ago, it downloaded the entire Docker container every single time. Now these Docker containers are about 700-800 meg in size as a rough guide for what I'm doing. And my home broadband connection, because the gateway is currently in the loft of my house, is 8 meg a second. So it takes a while to update the gateway. Thankfully, they have changed it and you can now download just the Delta. And now it takes about 3 or 4 minutes for it to build the image and for the new image to hit my gateway. Resin will run on Pi 0Ws as well. So you can have this really tiny, really cheap form factor PC that will connect to your local Wi-Fi, be it something like Bristol Wireless here or Monmouth MCC free Wi-Fi and all the rest of it in Monmouth, and call phone home over this secure network to Resin and pull the software updates down over municipal Wi-Fi. And these devices are what, £7, £8 each? And the sensors that you connect to them are £10 to £15. So for around £20 to £30 plus your time to put them together, you can deploy a fleet of tens, hundreds, potentially thousands of these things, and they all phone home and they're all running exactly the same firmware thanks to Resin and Docker. My devices, they've got two different types of radio on them depending on where I'm deploying them, one of which is the LoRaWAN stuff that I was talking about earlier, it goes via the Things network, the other one is standard Wi-Fi, but either way, it all ends up in my influx data stack. So I can deploy Arduino-based devices that run off solar power into the farmers' fields, and I can deploy Pi 0 devices into shops or on lampposts in the street, and it all feeds back to the same data source. So we can do the analysis across a massive area. So that's kind of what the network and the devices look like. This is a rough example of what the graphs look like. As you can tell, this is shortly after the test cluster was spun up, by the fact that the data kind of starts there. I mean, you can even tell what kind of time of the evening I was working on this, for going on the timestamps. But this is a screenshot from the cluster for a device that's currently sat in my lounge, which is why... it's not on here. This is before I added the particle sensor. The particle sensor in my lounge, most of the time, says the air quality in here is fine. Every so often, it hits an air quality index number of about 250. Now, for those of you that don't know the air quality index, it's the US government standard for measuring air quality because the EU ones are decidedly vague. And anything above 50 is deemed probably not good. So the fact that my lounge keeps going to 250 every now and again, not quite sure what that is. I suspect it's the dog. The idea behind this sensor is that it can sit on the wall outside a shop, and that from that the shop can work and see how many people walk past, what the air pressure was doing, what the temperature was doing, what the humidity was doing. They can then feed that information into their ERP software. And they can, over time, build up this profile that says, okay, the last time it was 25 degrees and we sold out of flip-flops, we had 400 people come into our shop. And we couldn't cope. We didn't have enough staff. It's going to be 25 degrees this weekend. Oh, this weekend it's not, sadly. That would be nice. But, you know, it's going to be 25 degrees. We're probably going to sell out of sandals again. Let's bring in 5 additional staff to work this weekend to make sure that there aren't any queues at any of the checkouts. And this is what I mean about using data to make better decisions. We've got a thing in Monmouth at the moment where they're talking about relocating a kid's playground. And from one side of a field where it's next to a dual carriageway to the other side of the field where it's next door to Waitrose. I didn't realise this was going to be quite so contentious, but apparently it is. But what this kind of device would allow them to do, because the latest ones, as I say, have got the air quality measurements on it, is to put up several of these across the width of the playing field and say, look, here is empirical data that the air quality where we want to put the playing field is safer for our children than the air quality that's next to the dual carriageway. And because these devices send data back in real time, and because these devices are maybe 40 quid total to build, we can actually put them at head height for 3 to 5 year olds. Because when you send away for the kits from Friends of the Earth and all the rest of it, they say make sure that these are 6 foot in the air, 8 foot in the air.
2 drunks high.
And they measure, well, yeah, exactly that, 2 drunks high, yeah. And it's, you know, if they get tampered with or anything like that, then 30 to 40 quid, yes, it's a lot of money, but you can put another one back there and you don't have to wait for another one to be sent out through the post. And the ones that get sent through the post are literally a test tube that go up, upside down, I believe it is, hanging off the lamppost, and then you put a cork in the bottom of it, send it off for analysis, and you get the data back 2 weeks later. Whereas this is real time. And because we can put it at the height of 3 to 5 year olds, it means we can actually measure the air quality that the children are breathing in, not what the adults are breathing in. Pollution particles are heavy, they sink, so the chances are that actually the air quality is worse at child head height than it would be for adults. So, again, feeding that kind of data to the local council and the local planning department, they can then start to say, well, actually, yes, we will make a decision based on this. And it's using the Internet of Things to make better decisions. And I would argue that that is far more useful than whether your Wi-Fi toothbrush is sending you a text message to let you know that you haven't brushed your teeth today. Or whether your geofencing has kicked in and your kettle is currently burning your house down because you forgot to fill it with water before you left for the day. That's basically it. So, thank you for listening to me ramble and rant this evening. If you have any questions, I'd be more than happy to take them. I do understand that one of those questions may well be, is it time to go to the pub yet? By my reckoning, I think the answer is probably yes. So thank you very much.
Well,
I have a question. If you considered the profile of the people that shop at Waitrose and the type of cars they drive, and possibly the pollution may be worse at Waitrose than it is on the dual carriageway.
So interestingly, I haven't deployed these sensors yet in that area. But interestingly, one of the things that we do have problem with in Monmouth is parking and
so
the lack of available spaces.
Forward,
so there are cars that, you know, I for example, you know, I drive a Citroen C1, which is quite amusing because it's bombing up and down the motorway every day. But it's not. I don't use it as a city car at all. It's abused heavily. But it took me 25 minutes to find a parking space in a town that's got a population of 10,000 people. So if I'm driving around in my little car trying to find a parking space, and you know we do have, you know, the 4x4s that are executive, is that the phrase I'm
after? I would never shop at Waitrose because I'm from Southmead. When I've driven past Waitrose, I've just seen cars going round and round in the car park waiting for a car park.
It is a problem. One of the things that I've been asked to look at is whether I can help the local council better plan their parking.
Cool.
And whether we can look at distribution of cars throughout the day, and whether we can encourage people to come into park in certain areas during other parts of the day and stuff like that, using the data. And part of that will be, what does the air quality look like?
Yeah. But that A40 is murderous, so whatever you think of Waitrose,
yeah, the A40 is basically
the dual carriageway is murderous, and the kids' playgrounds are like next to it. I mean,
I was just making a cheap joke about people that shop at Waitrose.
I think open data of that kind of thing is really interesting because, you know, there's a great problem, isn't there? With, I don't know, maybe this is off topic for this particular meetup, but you know, there's a problem with convincing people that maybe they need to change their behaviours, and if we can show people empirical data that shows the impact of driving around the car park in your four-wheel drive with the aircon on, and you know, to their children, to the very same people's children in the playground next door, then maybe that'd be useful information.
Absolutely, and I think what we're seeing, and we are veering off topic slightly, but I think we're seeing some of that with the impact of the Blue Planet TV series on people suddenly being excited about recycling plastic. We've known about this problem for 15 years, and actually people didn't want to deal with it. But now that David Attenborough has shown that, you know, it's killing dolphins, then, you know, everyone's on board with it. And I have no, you know, I've got no problems with this. This is definitely a good thing. But one of the solutions for it has been to about 8 or 9 years ago, I think it was, might have been less than that, people started inventing machines that would take the plastic bottles that, you know, the government have announced today they're going to do the returns on, and convert them to filaments for 3D printer. And you can just feed these, you know, you cut them up and feed them into a hopper, and you get 3D printer filament out the other end that you can just roll up onto a reel and then print the next thing out of it. And that, you know, to me that's a fantastic way of recycling this stuff, because you're turning it into a new shelf for a fridge, or, you know, whatever it is that you want to turn it into. So I think it is awareness that is making people change their mind. And I think, yeah, if we can get this data into the open, then, you know, as you say, it could make a real impact on what's going on.
Any other questions for Matt? No? Well, that's great. Thanks so much, Matt.